Hello everyone, welcome back to my channel. Today I am going to discuss a topic on introduction to multi-value dependencies, means MVDs. Multi-value dependencies are the fundamental concept in database theory that extends the notation of fundamental dependencies. MVDs describes a scenario where a single attribute can be associated with a multiple values rather than a single values. Understanding MVDs is critical for designing uh, robust and normalize the database scheme. This is about the introduction to MVDs. Next, we talk about definition and the characteristics of MVDs. What is the definition of MVD? An MVD occurs when a single attribute or a group of attribute is related can be associated with a multi-values for another attribute or a group of attribute. This is known as the MVDs, means multi-value dependencies. Next is characteristics of MVDs. MVDs are non-transitive and they are represented a many-to-many relationship between two sets or attribute within a single reaction. Next one is notation. MVDs are typically denoted using the symbol. The symbol we can read as multi-determinants. This is the notation of MVDs. Relationship between the MVDs and the functional dependencies. What are functional dependencies? Functional dependencies represent one-to-one relationship between attribute where a single value or of attribute corresponds to a single value of another attribute. Means it's one-to-one. It is known as functional dependency. Next one is multi-value dependencies. Multi-value dependencies represents a many-to-many relationship between attributes, where a single value of one attribute can be correspond to a multi-valued of another attribute is known as multi-valued dependency relationship. For every functional dependency is always an multi-value dependency, but not every multi-value dependency is a functional dependency. This is the relation between the MVDs and FDs. Decom- Decomposition, position, and normalization with MVDs. Decompositions. MVDs can be used to decompose a relation into a smaller or more normalized relation to eliminate gathering and ensuring data entities. Next one is 4NF. The 4 normal form is the higher level of database normalization that requires the elimination of all MVDs in addition to eliminate all the functional dependencies. Next one is the BCNF, means Virtual Kobo normal forms. BCNF is another higher level of normalization that goes behind 3NF by ensuring all the determination and candidates keys. Implementation of MVDs and database design. Complex complex relationship, data integrity, queries optimization, and normalization. Complex relationship. MVDs allows the representation of more complex relationship between entities in a database, leading to more accurate and flexible data models. Data integrity. Popular identification and addressing of MVDs can help in improving data integrity by reducing and ensuring all the relationship of properties respected. Queries optimization. Understanding MVDs can also assist to queries optimization by enabling a more efficiency database indexing and accessing struggles. Normalization. Achieving higher level of normalization such as 4NF requires the identification and elimination of all the MVDs in a database scheme. This is the implementation of MVDs on a database design. Next one is identifying and validating MVDs in a database scheme. Attribute analysis, financial dependencies and normalization. At first one is attribute analysis. Carefully examine The attribute is a relation to identify the potential MVDs looking for case where a single attribute can associate with the multiple attributes. Function dependency. Analyzing the function dependency is a scheme to help the uncovered underlying MVDs and for every FDs is also an MVDs. Normalization. Applying higher level of normalization such as 4NF can relieve the presence of MVDs that need to be addressed. Advantages and disadvantages of MVDs. What are the advantages of MVD? Multi-valued sensor enabling more accurate responsibilities and representation of complex real-world relationship is one of the advantage. And next one is the improving data integrity by reducing reduction. And next one is a support higher level of normalization such as 4NF and facilitating more efficiency database indexing and query optimization. These are the some advantages of MVDs. Next disadvantages of MVDs are increased complexity in database designs and management. Next is the potential performance impact due to need of the more complex queries. Difficult in virtualizing and understanding the MVD's based scheme. Limiting support is in some database management systems. Next one is the practical application examples of MVDs in database management. Inventory management, e-commerce categories, bill in materials, and students course enrollment. These are the sum of the particular applications and examples of MVDs. Thank you. Please like the video and subscribe.